This is part 12 in a series of videos in which I am reproducing this ADM-3A main board. The ADM-3A is a dumb terminal. It was designed a long time ago and is an entirely discrete design. It's all TTL logic. Very interesting design. And in the previous videos in this series I got as far as going through and testing all the clock generation, the display counters, and we got on to the display drive signals and the character ROM. And that's what I want to focus on in this video. It's the part of the circuit where I've made the most changes, and this is the schematic for it. It looks very straightforward, but I fundamentally changed the way this was arranged, and so I need to make sure this is doing what it's supposed to. Fundamentally all it does is it takes values from a ROM, feeds them out into a shift register, and then shifts them out, and it then goes through various processing to mix it with other signals to generate things like the cursor and the like. But what I want to do here is just to make sure this mechanism for creating the signal output is correct. So what I've done is I've created a few ROMs, and the first one is just a very simple bit pattern that gives us all ones or all zeros. Now the situation is not quite as simple as it may sound, because the output of the shift register is controlled to a certain extent by a blanking signal. The display needs to be blanked on retrace, and there are various ways this is done, and also needs to be blanked between bytes from each individual character. So there's a blanking signal comes down, but the circuitry to drive all that is not yet in place, so we'll get some fairly odd artifacts coming out of the shift register, but we should still be able to see fundamentally what's coming out. So the way I've decided to go about testing this, I've tested it with a scope, but that can only tell you so much. So what I've done is I've commandeered a monitor from a PET, which is there, and I've hooked it up so that the sync and the signal lines are properly connected. Now that monitor is meant for a different refresh rate, so it will be a bit distorted. I don't want to use the real ADM3 monitor for testing this. It doesn't belong to me, so I can't really use it for this sort of testing. So I thought I'd just borrow a monitor off a PET. It'll give us a distorted display, but at least it will show what's going on. And to do the basic testing, what I've done is I've hooked up the video drive to the monitor from the output of the shift register. So we're looking at this point here. This is going to the monitor, and I have the horizontal and vertical sync drive signals also connected. So that's connected to these 2 points. And that's coming out of the additional connector I put on the board, which is why it's there, and then that all connects across to the monitor. The power for the monitor is coming from the bench supply separately. Normally it would be supplied off this board, but it's just easier at the moment to run it from the bench supply, and it's all hooked up. So I've got a ROM fitted that should give us the all zeros or all one bit pattern. So I'll just move the camera again so you can see the monitor, and I'll turn the supply on. So if you're seeing any flickering on the monitor, that's just an artifact of the camera, and there's no flickering evidence in real life. You can however see the retrace lines. The retrace suppression is in later circuitry that we haven't got installed yet, and the ROM is currently set to give a bit pattern of all zeros, so it's given us full white all the time. The reason it's white rather than black is because as the signal's processed, ultimately this signal is inverted before it makes its way out to the monitor. So I'll switch the font selection switch over. I've got a separate bit pattern programmed into the upper part of the ROM, and you can see we're now getting a different pattern. It's actually programmed to give us all ones, and the reason we're getting an actual pattern on the screen rather than just black is because of the inter-character blanking signal which is causing it to do this, and that won't work properly until we get the rest of the circuitry installed. What I'll do now is swap the ROM for one that has a more complex bit pattern. The next ROM has values that count from 0 up to 7 in one half of the ROM, and the other half of the ROM counts from 0 to 31, and that fully tests the two main counters in the display circuits. So if that's displaying properly, then not only does it prove the ROM is working correctly, but it also proves that the counters are counting correctly. So I'll just get the ROM swapped out. I'll turn the power off first. Okay, turn the power back on. And so you can now see we're getting a pattern on the screen. If you look closely, you can actually see the count values. I doubt you can see it on the camera, but I can see it when I look closely at the monitor. If I flip the font selection switch over, we should get the alternate pattern, which we do, and so that's working fine, and it does look like both timers are running the way that they should. So finally, with this part of the circuit apparently working, we should be able to actually kind of display characters on the screen. It'd be very messed up because, as I say, we don't have the other control elements in the video signal, but we should still be able to see the characters kind of in the background superimposed on the noise. So I'll get the ROM swapped for one where I have all lowercase a's in the lower half of the ROM and all lowercase b's in the upper half of the ROM. And I'll turn the power back on. Again, I don't know how clearly this is coming out on the camera, but I can now see uppercase A's all over the screen. Screen's distorted. As I say, this monitor is not meant to run at this refresh rate, so it is distorted. It's cramped at the bottom and expanded at the top. Width's about right, but again, it's not linear. But that's just because this monitor won't work properly at these frequencies. Okay, if I now change the font selection switch, we should get uppercase B's, which we are. So that's all looking like it's working correctly. It does appear that the ROM and the shift register all work properly together, so that part of the circuit does appear to be behaving itself. I'll move the camera back to the board and we'll look at the next part of the system we want to investigate. Okay, things start to get a bit complicated from this point forward, and as I say, we were looking at the signal here, so that's what I'm tapping off here to feed to the monitor, but it now goes through a series of gates, and the idea of all this is to mix the signal with other signals, and in particular one of the most important ones is to generate the cursor. And the cursor is it's mixed with the video signal, but it's done in such a way that the data value being sent to the screen is actually inverted in the cursor location, rather than just it's not just a white block. And the reason that it's inverted is because you don't want to completely obliterate the character the cursor is over. So if it's an uppercase A, for example, if the cursor's not on it, it will be white on black. But if the cursor's on it, it will still be an uppercase A, but it will be black on white. So that's the reason it's inverted, rather than just purely writing a white value. So the way that the cursor is generated is relatively straightforward, but the overall circuitry gets fairly involved because it involves lots of different elements that can influence the cursor. So just a brief explanation as to how the cursor is generated. So if you recall, the characters are generated by scanning values out of the character ROM, which is the ROM we were just looking at. And then depending where on the screen those characters need to appear, their location is controlled through a series of counters. So there's a counter that counts the number of lines, and there's a counter that counts the number of columns, and then there's another counter that keeps track of where in each particular character row we are. And the way that the cursor is generated is, if we take one of the counters that is used in this character position control, then there's another set of counters that is used to determine where the cursor is supposed to be. So the first counters are scanned continuously and continuously update the screen. But if the cursor is meant to be in a particular location, then the way this works is there are a couple of magnitude comparators that are used, and the count from both of the counters, the one for scanning the screen and the one for the cursor, are fed into the magnitude comparators, and when the count matches or falls within a certain range, that is when we are in the location where the cursor is supposed to be, then the output of the magnitude comparator is used to invert the signal going to the monitor, which is what is going on here. So in other words, what we're taking here is the raw video coming from the character generator, and we're effectively mixing it with the output of a series of magnitude comparators. And if you look at the input to these magnitude comparators, you can see that we have row count being compared with the cursor row, and it compares it on a bit for bit basis. And what it's doing here is just checking to see if where we are in the screen should have the cursor displayed. It's complicated a bit further, so we've got this extra bit of circuitry up here, and the reason this is here is because there are two modes that the cursor can run in. It can either be a full block like this and fully replace the character with the inverted version, or it can just be the lower portion, I think it's the lower two lines, where you will just get a little line cursor, underline cursor, with a character above it. And then of course you have the different modes where the screen can be refreshed from the bottom up, or can be scrolled up from the top. So there's quite a lot going on here, and it makes the circuitry quite involved. But it's all based around comparing the values in the two counters. The counter for the screen scanning and the counter for the cursor position. And when they all match, so that's when we're in the right row and when we're in the right column, then the value that's displayed on the screen is inverted to give us the cursor display. So the next components we need to install, of course, are these. So these will allow the cursor location to be generated, but of course this on its own won't work, because we also then need to have the cursor location counters installed as well. So I need to install quite a few components. There's a few discrete components as well I need to install, but it is just mostly ICs, and then once that's done we can check to see if the cursor is appearing, and then also see if we are starting to tidy up the video, because again, part of this circuitry is to blank the inter-character positions. So a lot going on in the cursor generation circuits, and we'll go through that in a bit more detail in the next video. Okay, so as I said, quite a few additional components need to be fitted to get the cursor control and blanking control circuits working. They're very involved and interdependent. So I've been working my way through fitting the various parts and testing them as I go. These are the magnitude comparators that are comparing the position of the expected cursor with the current scan position on the screen. But these obviously require signals from various counters to determine where the cursor is supposed to be, and also what mode the cursor is supposed to be in. So I've been going through fitting the required parts, and we come to this circuit. So I've spared you the testing for this. It is very involved. I haven't done the part of the top right hand corner yet. I've just been focusing on here. Now unfortunately I can't go any further with this in this video. I have ordered the parts for this, but unfortunately when they turned up they didn't work. One of the complications in designing and building vintage equipment is procuring parts, and this is one of the reasons I don't provide vendor specific parts lists. But what makes it even more difficult, you may have seen my video I posted a short time ago about the problem in getting parts shipped, and quite often the shippers just don't know how to pack them and they get damaged in transit. And for these circuits I need quite a large number of counters, and the counters are used to keep track of where the cursor is supposed to be. So the parts turned up, but this is how they were packaged, and this is probably the worst I've seen. This was just in a jiffy bag, and it would be better if they'd just thrown them in the jiffy bag. Years and years ago I built machines. I was interested in high voltage, and built things like Wimshurst machines, Van der Graaf generators, and basically the way you generate very high voltages is to have an insulator touching a conductor, and then you rub them against something such as the inside of a jiffy bag, and you're guaranteed to generate tens of thousands of volts on the surface of the insulator. And so sure enough, I ordered these parts that I need for the next phase of the build, and they turned up like this, and not one of these works. They're all completely destroyed. There would have been tens of thousands of volts generated on this during shipping. This is it's just dumb. There's no other word for it. This is just stupid. So unfortunately there will be a bit of a delay now while I get some more parts ordered, but I'll demonstrate how far I've got through the process. As I say, I've been building this in a step-by-step process. If you know how the circuits work, you can fast forward or skip through that part of the video, but I'm going through this stage by stage for anyone that's interested. One very interesting comment that was made a few videos ago was that the process is a bit like learning software. And it's a very intuitive comment, because this process that we're going through and this particular machine, you could do a parallel exactly matching project in software. So in C++ or similar language you could construct this machine in software using exactly the same principles and creating the same object-based building blocks. It would work in exactly the same way, but in a software environment. So I thought it was quite an interesting comment, and that is kind of the approach I'm trying to take. I'm trying to break this down into individual blocks, because if you look at the entire schematic as one big schematic, it just looks like an absolute rat's nest and maze of circuitry. But when you break it down and look at the way that each individual part of the circuit works, then it becomes quite easy to deal with. So for example, if we look at this component here, this keeps track of certain parts of the cursor production. So effectively, when the cursor is moved, if any data comes in, or if the cursor is moved using the cursor arrows or whatever reason, then this counter is incremented or decremented. So it's an up-down counter. It can be counted up or counted down. And then the CR1, CR2, 3 and 4 outputs are the ones that go to the magnitude comparator that's used to trigger the output and invert the video whenever we are effectively scanning over the cursor position. So it all starts making sense when you break it down. But what it does mean is that an awful lot of this has to work before the video you get out starts to look as it should. So we've looked at the output of the character ROM. So we were looking earlier at the output of the shift register, but I said this goes through several other stages, and part of that is to be merged with the information that generates the cursor, but also that creates the blanking. So when we move between characters across the screen, this signal up here is used to temporarily blank the video trace, and make sure that we don't get any artifacts between the characters. But because this in turn is fed from other circuits, including these, it means that we've got to get a lot of this working before the characters start to look proper on the screen. The cursor won't appear yet because I don't have the components for the counters. As I say, they were damaged when they arrived, but I can still get the rest of it working to allow the inter-character blanking. So I fitted all those parts. I've gone through the testing. As I said, I spared you that. It was quite tedious and very involved, and entailed fitting another 54 ICs. So as you can see, we're now getting an awful lot closer to getting all the ICs fitted. So I'll move the camera, we'll power this up, have another look at the screen and see if it looks any better than it did previously. I've moved the video feed for the monitor to a position further down the chain. Again, there's no flickering evident on the monitor in real life, that's just the camera, but hopefully you can see now that it's producing quite nice clean characters. We're still getting the retrace lines. They won't disappear until we get the part of the circuit in that deals with removing those. But hopefully you can see that the characters are nice, clear characters now, unlike what we were getting previously. They still won't look right because the information that's required to fully clarify them on the screen is not yet all being produced. And also certain pins are floating, so you can see there are artifacts on there as well. If I switch to the alternate character sets, we should change to all uppercase B's. So you can see that that's also working, so we can select the correct character from the ROM. Incidentally, I do have the full character set images, so I do have the full character sets in a binary file that I can use, and I've got one for the lowercase and one for the uppercase characters, so I can reproduce the original font exactly as it should be. But also I'll be able to produce a second character set, as will anyone that builds this if they want to. Also, I've been testing things such as the different scan rates for the display. So we're currently on 60 Hz. If I change it, you'll see it changes and looks a bit different. But as I said, this monitor is not actually designed for either of the scan rates we're using, so it won't look as it should. Also, the 12 or 24 line doesn't work yet because, again, that's what one of these counters does. It effectively skips every second line of characters. So it's all coming together, it's starting to work. So once we've got the cursor working, then the next thing will be to fit the SRAM and see if we can actually start producing proper text on the screen. I'll burn a ROM with the full character set in, and in theory then we can start producing text. Once that's working, the next step will be to start working on the serial side of things. So I will be making these available, but I just want to wait until I've got far enough through the testing to be fairly confident that anyone wanting to build one of these won't encounter any major problems. If you are interested, the current drawn by this at the moment, the power has gone up to 750 milliamps, and so as I said, it will keep climbing until such time as we get all the parts in, but it hasn't spiked, it hasn't done anything peculiar, so we don't have any serious contention or anything going on the board. Obviously all the heat sinks are still cold. There's this load's spread across 3, so I don't think we're going to encounter any problems with it overheating. Okay, that's it for this video. As I say, comments welcome, and it shouldn't be too long now before we start getting some text on the screen.